Hello, hello. This is very late for me, but in this short session, I will attempt to continue and find a solution for my last discussion of integrating a finite state machine into the ECS system, or the ECS paradigm, if you will. And in the previous section, I looked over a couple of articles that were on the internet on this topic, and none of them actually said anything conclusive about this. So I'm gonna go on my route because I already wrote in the old engine a state manager, which is like a finite state machine where you register a priori, you register the states, and then you have like a trigger state, then you have a manager that's updating every frame. But I want to first ask ChatGPT just for fun, because it's late and maybe we find out something new here. So I want to ask ChatGPT to build me a finite state machine. Write me a finite state machine in TypeScript. Just this. And we'll go further than this. So ChatGPT says creating a finite state machine in TypeScript involves defining a set of states and transitions between these states based on certain inputs or events. Let's create a simple FCM for an illustrative example. In this example, let's assume we are modeling a simple traffic light with three states: green, yellow, and red. The transitions will be straightforward. Green goes to yellow, yellow goes to red, red goes back to green. We'll create a class to represent this FCM. So your traditional state here, and then have the current state, change state, and that's it. Okay, but let me repurpose this question. Write me a finite state machine in TypeScript where each state has a priority and states can be queued, because this is exactly what I have here. States can be queued, and each state can occupy multiple ticks a variable number of ticks, e.g. processor loop or GPU loops. I think I'm making a sense here. Creating a more advanced finite state machine in TypeScript where each state has a priority can be queued, and each state can occupy a variable number of ticks. Like in a processor or GPU, loops involves more complex logic. Give me a break. It's not that complex. It's just a class where you register the states. You have the current state, the default, the queue. Why is it complex? Define. So in this implementation, we will define a state type with name, priority, duration. Correct. Implement a method to add states to the queue sorted by priority. Correct. Implement a method to advance the FCM by one tick, updating and changing state. Okay. Here's an example. Name, priority, duration, state queue, bomb ticks, next state. Okay. So this is exactly how I implemented the state manager back in the day. Where's the structure here? Yeah, where a state item has a name, priority, and an instance. Now, instance is actor state. Okay, this is a state class actually. It's an instance of a state class. Because my thought here was that, let me find that class and pin it here. So my thought is that you register the states in advance in memory. And then you simply call the instance, so you don't have to create an instance each time you go through the states. Let's see. Create item, instance, enter, apply. And we have an enter, an exit, and update. Wow. To me, it's kind of interesting that I've thought about this without knowing any theory on the subject. Let me check something else. There's a book online, Game Programming Patterns. I actually watched this guy presentation yesterday, and it was interesting, but nothing on this particular topic where state meets ECS. I mean, he had a particular ECS implementation that I didn't really like because it was for roguelike games and not for what I want. So I want to have states that can be cancelled. Let me show you an example. Where is this? Is the game planning? I keep forgetting my folders here. Ideas. So I want to have the states like in Dota, just like how I implemented here in the previous version of the game, where you can actually cancel an action. So you can cancel the animation in the middle of the animation so that the final action, dropping a bomb, doesn't happen in case, let's say, an enemy attacks you. So that's why the majority of articles and videos, tutorials on implementing finite state machines in alongside the ECS don't work for me. Finite state, but okay, so it's ostensibly about the state pattern. Okay. Side scroller, handle input, set graphics. And also in my final state machine, I don't have more than one state. So that kind of simplifies the thing, the code, the logic. I think I read this article many years ago, like in 2018, maybe. The state machine can only have one state at a time. Our heroine can't be jumping and standing simultaneously. A sequence and events, enamel switches. Okay, so I think our challenge will be to have this into a generic in our library. And let's see, another challenge. I think another challenge is related to the tick. What exactly tick means? It doesn't mean a frame. And in my engine, my previous engine, a tick meant that a tick is a frame. And that's not really a great example, because you want to execute stuff that you might want to use floats. So, but anyway, we'll see. Okay, so let's write this library, this new library, which we're gonna have in our project. It's gonna be called FCM. Okay. And I will also need tests for this one. I want to write tests right away. So let's copy a boilerplate of maybe bitmask. Yeah, let's copy a boilerplate of this one. So just package. I don't think I need Webpack at this stage. Add these. FCM. Okay, so Webpack, I don't need Webpack. Just TS node. Okay, I think I need all these. Okay, file loader. I don't need a mock. Let's see, src. Oh, test environment node. Okay, we have the class state manager already. How should we call this? Let's call it state manager as well. I'll do a little bit of setup here for the project. So language JavaScript is good. TypeScript, TS-lint, automatic configuration. And by the way, this should be for Node, coding assistance for Node. Right. This is important. The actor state. And I think I'm gonna rename these. Actor state. Actor state status. Which is this, and then enter, I guess, boolean, exit void, update boolean. And this should be iState instance. No, iState. It's like the iState class. So question here is, is this a state of a component of or of an entity? I don't think I want to make this explicit because either entity and component can have a state, right? But I have to answer that in an ECS system. So iState class. Let's just name it like that and I'll see. Maybe iState instance, because this is an instance actually. It's not a class declaration. So let's see. No. Public. And in the constructor of the state manager, I actually have the entity injected. That's interesting. Default state name. As we know, I don't want to have a state as string. I mean, it's faster to have an integer, but I'll keep the string right now for the moment. And states should be this should be a map. A map of a string wait, how do you define map type script? Wait, am I dumb here? Is it like this? I totally forgot. Where am I using map here? In the demo. Okay. It's map string iState item Map default state name. How do you initialize something and then I guess you throw an exception. But then, okay, if not current state, then current state. Okay, there's no current state being set. We use this, so I don't need it. And register state. This states delete state name, which I actually want to be state ID. Default state ID. Current state is null, then current state equals this state get ID. Current state instance, enter apply current state instance with arguments. State doesn't exist, just don't execute anything. This means the actual current state will persist until it's replaced valid one. Current state, no, okay, new state. New state is I state. If there's no current state set, means current state, new state. Okay. If there's no current state set, that means we can start executing the new state, new requested state. Current state. If current state item instance status is state finished, state status, then new state priority or new state priority is lower or equal with new state priority, and new state ID is different from the current state ID. So wait a second, if the current instance status is finished, or new priority is lower and the IDs are different, might be a mistake here, because I say that if new priority is lower or equal with the, it should be the priority was inversed in it's a good question for ChatGPT actually. Should priority be based on the higher number or the lower number? Trick question. Higher number indicates higher priority. Lower number indicates higher priority. Yeah, so exit current state if it's finished or the new state has higher priority. Then current state instance exit. Current state is You know what's interesting here? Exit could be on exit could be on multiple frames actually. Should we just exit and then wait for the next tick? Current state. Because what I'm doing here, I'm just entering the new state. And this is the update. So this is like a system. Current state. I think I've answered my original question. Let me finish the refactoring of this current state. It's very interesting that in the constructor I had this entity which I never used here. Okay, so let's see, current state. Set default state. Set default state ID. And now this looks like a system. So this is like a state manager system actually. Wow. Holy crap. Only the only difference here is that state manager was made to operate on a single entity state. So I guess if I would go deep enough here, I would need to have a separate state per entity. Which I don't really like as a separation of concern. But think about it that previously state was attached to one entity. But now if I want to transform this into a state system, like a state system manager, I would call update. So what do I want here? I want it an individual state manager per entity, or do I want a state system? Because a system is like this. So state manager system. It's like construct query as state. So let's say that all the entities here that have state, a query with entities that have state, entities that have state are supposed to have state. Then update is like this query execute for each entity and you would have entity would be something like entity state manager, although on entity shouldn't be any method. So how about how this should be attached to an entity? So I guess the only question here, let's put this question to ChatGPT. I have a bunch of entities who are supposed to have state in an ECS type of game engine. I have created a state manager class which manages the states of one entity on a period of ticks. A period of ticks. That's very confusing. How should I integrate these concepts into a system, given the fact that entity is just an ID and a component must be only data? I think I now understand that this is a state manager system. ChatGPT is going places that are irrelevant, but here's how it is. Need a system that queries all entities that have a state. And this state system will process all the entities one by one. The question is, do I want a state manager per entity? Let me see here. I think what I'm missing here is register states with entity and register state manager and entity and states. No, actually register state manager for entity. And then for each of these, it will be this managers, state managers get, say, entity ID, update. That's what everybody on the internet with their tutorials should have written, that it has to happen. So for every state manager registered, you fetch it, you update it. This is exactly what it has to happen. And I'm gonna put it here. Actually, let me write one test for this. Describe state manager. Okay, let's do register state. State manager. Okay, small mistake there. Register state. So let's see. Idle 0. Idle new idle state. Oh shit, actually I wanted this, which is status I think this would be better if it would be some sort of abstract class, maybe. Enter, exit, update, true. Then sm get Okay. Why is this commit so complicated? Let me try to do it from here. Okay, it sees every commit. Added glhf state vsm package. What did I do here? Keyboard. Fixed source map issues. And that's it. And at least right now, I have a state machine here, which is very simple. Of course, I need to test every line of the code until I have 100% coverage. But now I understand that this is my goal. So my goal is this. Perfect. Tomorrow we'll integrate all of these with the system and the game, and we'll see how it works. So that's about it for today. Thank you for watching and see you later.